Okay, the next panel is starting now. It is on the limits of cryptography and how they relate to intents. Everyone, please welcome the speakers.
All right, so I think we'll have 40 minutes of packed discussions today. And so to start off, can each panelist please introduce yourself, your project, and answer the question, how does your project use intents? Yulia.
Okay, so I guess I'll start. So I'm Yulia. I am a cryptography researcher at Anoma. I feel like everyone probably at this point knows that Anoma is intent-centric. But if you don't, just a bit how Anoma uses intents. So intents are kind of built in the core protocol. So on every layer, the decisions made are aware of intents, like at P2P layer, intents, like different nodes can subscribe to different things depending on what intents they are interested in. Or on the resource machine level, you have intent level composability, and instead of transaction level composability and stuff like that.
Hello, I'm Fede. I'm the founder of Lambda class on Aligned. I'm a little bit sleepy. 15-hour flight, and I'm from a developing country, so I might not know mathematics that well. So that's a small joke. So my project is Align. We are a CK verification layer that is cheaper and faster to run than Ethereum right now. In the future, it's an economic layer. In the future, it will be also a CK aggregation layer using Recursion or some Stark prover, probably the one from Starkware too. We're still talking with my friends. How do we use intents? So we will build a bridge where we use storage proofs. We prove that somebody deposited some money somewhere. We prove that, we verify it on a line, on the market maker sends a transfer to the address that the user wants to bridge money. On the market maker can get the money out from the first contract once he deposits the money on the second chain, and you do a storage proof. So we're using intents as a way of communicating between networks on changing the dynamics of the safety, like the user is not taking the risk, it's the market maker.
So I'm Louis, I'm the head of strategy at Starkware. For those who don't know Starkware, we are one of the leading company when it comes to ZK, more specifically with one product called StarkX and one network called StarkNet. When it comes to intent, obviously Starkware directly does not work in that field directly, but we do provide technology that we have seen a lot of teams using to create those kind of tools, like storage proof that Fede just mentioned, things like ZKML, and also DeFi pooling and Imbura. So we didn't see a lot of the variation of how, expressing through cryptography what you want and how you get executed across layers and across environment.
Hi, I'm Connor. I'm a solutions engineer for Celestia. I pick up the odd ZK-related tasks that we get. I don't know very much about intents, but I hope to learn more about them on this panel.
Hey, everyone. My name is Shumo. I'm known for the airport waiting guy on Twitter, apparently, because I was spending 3.5 hours yesterday waiting on the check line. And on my side job, I'm the co-founder of Nebra Labs. We're actually building on two pieces of Lego. The first piece is the universal proof aggregation layer. And the second piece is a proof aggregation-based rollup stack. I guess in my view, we're very, very related to intent because the kind of end game of a rollup stack, we need proof aggregation, and then we need proof aggregation to aggregate the validity proof with, we call it intent safety proof. Basically, with the power of the ZKP, you can actually snarkify the intent, and then you can actually guarantee the intent's execution at a settlement layer. I think this opens a big space for the intent, the full stack intent ecosystem. Yeah.
Got it. So to summarize, I think there's multiple different ways intent has been brought up. Yulia talked about Anoma resource machine, and we have bridges that, there's intents for cross-chain transactions, which is similar to what Shumo I referred to. Panelists agree that there seems to be different notions of intents, but the overall goal is similar, but the underlying implementation might be different. All right, so let's introduce the second topic here, cryptography. And how does cryptography relate to the way that your project uses intents? Yulia first.
Okay, so Anoma is providing information flow control. So users supposed to control the flow of the information they own. And to do that, you can start with transparent information, right? You have to, because if information is transparent, it doesn't matter if you want to hide it from someone, you can't really do that because everyone can see it, without your permission. So you need to start with private information. So that's how basically Anoma uses cryptography. Because Anoma is intent-centric protocol, there is intent matching phase and settlement phase. Intent matching phase is when intents get matched into transactions, and settlement phase is when transactions get settled on the blockchain, like ordered execution and all of that. And in both phases, we use cryptography to provide information flow control, basically.
In my case, it's pretty simple. As I said before, if an user wants to move an asset from chain A to chain B, we have to prove first that he has the asset on chain A. We do a storage proof, like we do a CK proof or validity proof, to be exact, of the state. And we need to verify that. On doing that on Ethereum is pretty expensive, so we do it on a line layer. On the other way around, when the market maker sends the money to the chain B, where the user wants to receive the money, we also have to do a storage proof that needs to be verified. So the way we mix intents on CK is by proving the state of what the user has, and we need to verify that before matchmaking and moving money around.
So I guess in the case of Starkware, the most direct work rate to intent would be the work that two companies that come to mind, Herodotus, which does storage proofs and similar to what Federico is talking about, and the folks at Giza that does DKML. And the reason why I bring those two up is because what intent is about, the way I understand it, of course, is you want to represent the wish, like what someone wants to do, and you want this to be executed in a trustless way and get him to have the best execution. And so what Giza does, for instance, is running a model, an algorithm, whatever, in a way that can be efficiently done in a VK, locally done, and use that information across the environment that they are trying to execute. So to us, the most important aspect is making our stack extremely fast, extremely efficient, for them to be able to provide the service that they want to provide.
It sure seems like privacy and secret information is a big part of intent matching, or at least you see it come up a lot or used interchangeably. A limitation of using ZK is that you can't have state that no one knows. Someone has to know whatever the secret information is, and when you do need to have state that no one knows, you often end up using other kinds of cryptography. You'll use multi-party computation with a committee or possibly a TEE. But anything's possible.
I guess from my perspective, because we're actually building a new ROP stack from scratch, a good part is that we actually can rethink a lot of fundamental design choices and make the backend underlying infra more friendly to the intent. And here the title is limitation of cryptography, not ZK, right? There are a lot of limitations of ZK. For example, like Connor just said, you need like a state discovery. For example, you need some kind of like a secret sharing. So before I come here, I actually just like reread the article, like cryptographic paper by a Harvard professor. His name is Boa Barak. He has this like a famous or infamous chart about thinking about after 100 years, what kind of a society we're living in based on the mathematical assumptions. The first assumption is P equal to NP. People call that algorithmica. And then the other one called cryptomania, basically like LWE holds, but no IO. And then the last one called Officetopia, I guess, basically exists IO, right? I think it really depends on what kind of like a fundamental cryptographic assumptions hold. If the IO hold, we pretty much can do everything, like Carrone said. There are some like witness encryption, all this like a moonshine. Cryptography is not practical yet, but maybe it's practical. So for example, Flashball doesn't need to using TE to build solve. But I do see a very immediate limitations for cryptography is that the speed. ZK prefer today is still like about 3 to 5 order of magnitude slower than native execution. In a lot of like MEV use cases, there is kind of like a timing game. I think if you want to know more about timing game, you should watch Justin Drake and Anna Tony's debate on bankless. So because of the timing game, all these competing parties, they actually want to get the transaction in pretty fast in the last second. So a lot of cases, it's probably not enough to, basically you are using a slower prover or slower cryptographic mechanism will give you a competitive disadvantage if you are using in this like a MEV timing game. That's one of the very clear limitations I can see here using cryptography here.
Okay, so I think we mentioned a lot of things right just now, and let me maybe direct the conversation to each part. And to summarize, I think we mentioned 2 things, right? So just intent matching that Yulia mentioned, and there's intent settlement. And then there's the capabilities of the cryptography, right? MPC or TEs or whatnot. And then there's the speed, right? So let's actually maybe first talk about intent settlement, because I think that's maybe one that relates to the most of the panelists here. And can you elaborate on how intent settlement is done and how ZK comes in, and what are the current challenges with that?
What is intent settlement?
So I would say this is what Fide or Shumo have just talked about, which is, or Louis have talked about it, where you use ZK to prove that certain conditions are satisfied, that something did happen on one chain, so that intent can be safely fulfilled.
I can go over if you want.
Yeah.
So in our case, like it's related to the second part, the speed or the cost. The 2 things are correlated in some way. If it's like if you are transferring, if you want to make transfers between chains very cheap, like a few cents, the verification cost cannot be very high, and the speed should be pretty fast so that you can move assets very cheaply. So in some way, speed and cost are a bottleneck for us. Actually, we wanted to create this bridge, and that's how we invented a line layer. It was like, okay, fuck, there's no way of checking Herodotus proof. We were working with Herodotus, they're friends of us. We wanted to do some things, and we realized that the cost was so huge that even with aggregation, it was not possible. We used Sharp, the prover of Starkware, we couldn't do enough settlements, or we couldn't like execute the protocol as fast as we wanted. So that's how we invented the line. So now we have it, so it's not anymore like we can verify like the maximum throughput we checked was 100K KZG verifications per second. Obviously, it's an economic system, like it has a few billions. We have 2 billion committed from operators so if it's something way bigger than a few, I don't know, like $1,000, I wouldn't use it, or a few million. But for something that is fast and cheap, it's good enough. So we implemented it actually to solve that intent-related problem.
Right, so the limits that you found is really aggregation is expensive.
Yeah.
You want to do it the proper way, right, using cryptography. So therefore, a line layer have chosen to do economic aggregation, economic security, right, for aggregation first.
On the first part. The second part will add traditional CK aggregation or validity proof aggregation or recursion. But for now, due to speed and cost, that was our first take.
I can also expand on tiny bit. As Federico very clearly mentioned, the current speed is a very huge limitation how you can synchronize and therefore share intent between environment, especially as heterogeneous environment. And so the reason why so none of the L2 right now, none of the ZK-L2s are bottlenecked by provers. But what they are bottlenecked in terms is latency. We are able to prove gigantic proof, but it will take 8 hours. And honestly, there is no bound at this point of the size of proof you can do for any meaningful computation. But the reason why you want to speed them up is, first of all, to reduce the cost, because less time, faster reduction of cost, but also to reduce latency. And it gets to a point where when you get to the theoretical limit of this is when you get to a point where latency is so slow, it's so fast that you actually can do proof verification at each block. And then at this point, you can just shared sequencing become an extremely simple thing to do. We love to, I'm not a huge lover of shared sequencing personally. I think it's a bit complex. I find it complex to implement, but at least if you were able to have like recursive proof at each block, at the tip of the chain, that would sort of make sense. You could imagine partial execution on one end and finishing the execution on the other side. And so this is where I'm quite excited about the sort of like technological progress we're seeing right now. Starkware just showed a couple of days ago an improvement that is going for, our new prover is going to be 1,000x faster than our current ones, and is estimated to be roughly 20 times faster, 10 to 20 times faster than anything available in the market. I'm able to run on my phone right now, using Stu, something that would cost me, actually I wouldn't get the same, I would need probably like 100 top machine on AWS right now to do it with our existing prover. I can do it on my phone at this right now. And so this is sort of like the improvement we're seeing would dramatically improve interoperability and therefore intent as a consequence.
Is there a catch though? This is with Circle Starks, right?
Yes.
Like recursion is still, not counted within that benchmark, right?
Oh, no. Just a straight, can show you on my phone right now. I have someone so our new prover is in Rust. So one was C++, so we couldn't compile it easily to other platform, but now it's in Rust. So a colleague of mine was trying to make a test and just compile it as an app on my phone. So yeah, it's straight up 2 to the power 18 Poseidon 2 hashes. I get to 200,000 per second. And with an M3 Max, basically like the top laptop, top Mac laptop right now, you get to 1.3 million. So this is like the sort of hashes per second. This is a sort of speed up that will reduce dramatically latency and therefore massively improve your interoperability.
Yeah, on recursion in Starks is very simple because it's a Cairo program. So everything that improves the base layer of the prover also improves the recursion. That's not always the case in every proving system. So in this case, it's like every big improvement on the proving will make the recursion easier and faster.
Yeah, and like I said, this doesn't account for recursion. It's not like including recursion within the proof itself.
Shumo, any comments on recursion?
Oh, sure. I think I agree with what Luis and Fede said. Like I think for prover speed, there are two things. First is the raw speed, like how many actual overhead proving compared with the native execution, or the RISC-0 folks using the stimulated RISC-V CPU like hertz. I think this is a good metrics. The second one is people call that continuation or sharding, whatever. Basically, the ability to spread this proving workload to multiple different machines. So let's say you have the same computation power per machine, the ability to spread the computation over 100 machines will make the proving faster than ability to spread the computation over 10 machines. However, I want to mention another about previous point about intent settlement, different from the prover speed, is that I do think it's actually important to, at a settlement layer, to provide the intent guarantee. If you read the Anoma intent white paper, I actually read that. So there's like a fancy dependent type-based definition of intent, but I can provide a simpler definition. I think a lot of intent you can express as a state predicate, which means, hey, like this is you basically enforce a constraint or post condition on the execution to say, hey, after this execution, what kind of invariant on the state? A very simple example here is that So let's say I'm a trader or degen trader. I want to do this trade. I want some like a price guarantee, right? This could be I feel like a lot of intent on the language level can be expressed as a state predicate, and you can actually using ZK to verify the safety or like ensure the state predicate, so that like you can 100% guarantee that this intent execution is successful. I think this is a very interesting design space. I think we should explore more and head into. Yeah.
I guess I can add to that from the Anoma perspective. Intent level composability, right? I mentioned that Anoma provides it. So I feel like this is how you can basically prove that the intent was satisfied. So what is an intent? When I say intent, I mean unbalanced transaction. And intent level composability means that we can compose unbalanced transactions into balanced transactions. And then balanced transaction is like transaction that you usually think about. And then because an intent is an unbalanced transaction, which is also a transaction, it includes these predicates that Shumo mentioned. So basically, you have this connection between the intents and transactions, and if you prove that the transaction predicate is satisfied, it basically means that the intent predicate is satisfied because intent is a part of this transaction that is settled.
Everything's coming together. Connor, any comments to that?
No comments to that, but I am curious about what is the, not to change the subject too much, but I'm curious about what is the reason privacy is talked about in the context of intents.
Yep, that's the next topic.
Okay.
But maybe let's conclude. I think we just discussed about intent settlement. There's predicates that we usually have to prove, and in with recent improvements, everybody should go check out the Starkware paper, right, on proving these percent hashes. I think the limits of cryptography is being broken, over and over the last couple of years. That we're getting closer and closer to real-time secret proving, and I think this is something that will happen, and it's very exciting. And maybe we don't need TEs, maybe we don't need crypto-economic security in the long term. So let's talk about intent matching. And this is something that Yulia discussed at first, right? Anoma, it's not just for settling the intents, but it's also a network to match these intents. And this part maybe require a lot more fancy cryptography that Shumo has just talked about. And so the question to the panelists is, describe how cryptography comes into intent matching. And I think Yulia, maybe you should go first here.
Yeah, sure. So just to answer first the question of why we want privacy for intents, I think I can think of two main reasons. Maybe there are more, but I can think of two. First one is, so what is privacy at the intent matching? You basically want someone to match your intent with someone else's intent. Some party that has more computational power, but you don't want them to know what you want because it's something that you don't want to reveal. So privacy here would be to make it somehow that this party finds a match for you without knowing what you want. And two reasons for that. First of all, it's nice when you can keep your things private. That's why you want privacy on transactions. That's why you might want privacy for intents. And another reason is that for malicious actors that see your intents and base their decisions on that, if the intents are private, they cannot see the intents and therefore cannot base their malicious actions on that. So these are the reasons for privacy. And next question is how to achieve this privacy for intents. And we did a little bit research about that, and it turned out that it's not very easy to do. Yeah. So on the settlement layer, like when the transaction becomes settled transaction on the blockchain, it's more or less figured out because there is Zcash, protocols like Zcash, there is Penumbra that went live. It's amazing, right? And these things are more or less figured out. But when you go to intents, like not only there are not many intent-centric protocols, but I don't think there are intent-centric protocols that support privacy. So there is like approximately non-research in that area. And so it's like not very clear how to do that, especially when you state the question like how to get like someone to match your intents without knowing what you want. And so back to the research that we did, like the short answer would be maybe MPC and maybe TE, and maybe not FHE.
Maybe just for the audience, can we dumb down intent matching a little bit, right? So there's this famous problem in MPC, which looks like maybe Shumo knows this example. Do you want to explain?
I'm thinking about a different example, but happy to explain a little bit. So basically, let's give a very simple example. Because when we talk about intent, a lot of cases we need to talk about auctions, right? Because inevitably, you are getting into this kind of like an MEV supply chain issues. So let's take a very simple example. Let's say we are doing the first price auction, which means we have an auctioneer, we have bidders, whoever has the highest price gonna win. It's very hard to do that privately, just purely using ZK. The reason here is that you need to kind of encrypt the bid, then there are gonna be some people to do the decryption, and essentially this is need like a computation on private data. So then you probably need ZK plus FHE, or you need ZK plus MPC, and people are not happy with some of the cryptographic securities of the MPC because it's like it's not super private in a sense, right? So, but in many cases, we need to run this like a first price auction, not just for, I guess for privacy, there are two reasons. One is for idealistic reasons, like we do want privacy. Privacy is normal. And the second reason there is like kind of like a capitalist reason, because privacy can have a like better capital efficiency in dark pools in many auction protocols. So the reason that I guess like Flashbot, they have to using TE to build the swap because you just cannot using ZK to run like a good first price auction. So this is basically the example I want to take, yeah.
Yeah, so I guess TEs solve the problem. That's why Flashbot use it. But Anoma is planning to do MPC for this, and there seems to be a whole spectrum of solutions to solve these type of partial information matching problems. And yeah, Louis.
So I mean, when it comes to, I think I'm pretty much agreeing with Shumo here. With when it comes to matching, centralization, like there is a design space that I think is commonly under use, which in cryptography is called the trustless car dealer. So the idea of someone who actually organizes a game in a way that he actually can cheat with it. And for most privacy environments, this person is has a reputation to some extent. And so this sense, TE tends to be for me like I hate TEs, I'm a ZK guy, I cannot like them, but for some very specific use cases where you want credible privacy, I think TE can clearly fit the bill of organizing those markets and organizing those dark pools as well as those first price auction. It's so much easier to implement, basically.
Yes, but does cryptography have the answer to TEs? Any takers to this question? Connor, Fide?
I'm not completely sure if you can directly replace any TEE app with cryptography, but it certainly seems like you could just get like 100 or 1,000 participants in a big multi-party computation and have them be responsible for keeping all the inputs secret, and then you could have probably as good as a 1 out of n, where as long as they're not all colluding to reveal the secret information, it would remain secret. Not entirely sure if that could replace any TEE thing. And also, of course, there's the massive overhead. What I just said would be pretty much impractical.
Yeah, I guess I have to push back a little bit because TE is cryptography. Like if you look at the construction, TE use a lot of cryptography. It's somehow we kind of say, hey, like you're not cryptography, I'm cryptography. I feel like that's a little bit wild. I think the biggest issue of TE, in my view, is that these like centralized forces like Intel or AMD or NVIDIA, they are the parties have completely control the technology. I think my view on TE is that we should use TE as a kind of a training well of this like fancy cryptographies. There are many, many things you can use TE. I think a lot of people are very interested in like a single shot signature these days. These all can very just like using TE to do it, but we need open source TE implementations, maybe some like a RISC-V or like open source enclave so that we have less security risk.
Yeah, I think this is a great call to action, which is TEs. Yeah, they use cryptography that can be made better, and currently what's on the market maybe does not really suffice for all the use cases we want in Web3. Yeah, so I guess for a question for Yulia, do you think Anoma will utilize ETEs, or will it be MPC-based matching?
So the the thing is that using MPC or TE is about solving, and solving is application specific, so it's up to application developers what to use basically. But I think it's a good idea to provide some kind of default solution for privacy preserving intent matching. So I think both approaches could work, but my personal opinion is that TEs are more realistic in the short term because there are a lot of questions come up when you try to implement the same thing with MPC. For example, if we consider like fully private intent-centric protocol where intents are matched privately, and then the transaction that created as a result of it is also private. You need to somehow combine these privacy parts together, and in TE it's more or less easy, straightforward. You just do matching in TE, then you create a transaction using this privacy-preserving tool like Taiga, Anoma's Taiga, it's a privacy-preserved instantiation of the resource machine. You use that, produce transaction, everything is done. In case of MPC, it's much less obvious how to do that because basically you would have to run Taiga either as an MPC protocol or if you decide to ask different parties to compute different parts, you need to connect these protocols, these MPC protocols, the one that matches intents and the one that turns the matched intent in some form into transaction together, and there are a lot of questions about that. So I feel like what could make sense is to, for the short term, explore TEs, but also explore MPCs in the meanwhile so that you can have both approaches because I don't think either is perfect or necessarily better. It's all about trade-offs, and it makes sense to consider just both.
That makes a lot of sense. So TE is first. We'll add MPC when it's ready, and it's really complement each other. So question to Fide. You run one of the largest dev shops in this industry. You guys do a lot of ZK work, right, with Starkware, ZK Sync. Do you see TEs being something that projects are asking for? Do you see MPC, FHE being something that's up and coming, where there's a lot more projects? What are you seeing in the space?
Sure. So we did quite some work with TEs. The problem, and I think this is good for cryptographers, at least for now, is that TEs API are fucking horrible. They don't work very well, so the competition is the bar is pretty low. Intel is working on a few things that are pretty cool, where it will be similar to a RISC-proof or like a RISC-V thing where you write on top of it and anything will work. Until now, you have to use very low-level things that work until they break. There's always some strange edge case, at least that was our experience. The last time we wrote something pretty big, and by big I mean more than 5 to 10 Ks. Line of code inside the TE was like 1 year ago, so maybe the ball better, but my experience was pretty bad the last few years working with TEs, and nobody is asking to use it. The biggest use case I know is the one that has been mentioned, that is flashbots. Apart from that, I'm pretty bullish on FAG. I love the work done by Sama. I think it's like the Starkware of, I believe Starkware is the most advanced research or engineering company in the space, at least on the CK part. I do believe that. I hope my other clients don't get angry, but it's the truth. Removing the application layer, or more like I think the circle structs are amazing. Well, Venus actually, I think it's also pretty cool. But I'm not a big fan of MPC. It can be useful, but I think it's not that far away from a multisig in some way. So yeah, I'm a big fan of FEG on CK.
But Zama does use MPC.
Yeah,
it's MPC and
I,
FEG.
I know. Yeah, I have seen it. I'm not a big fan, but I understand it's like it's a practical thing. The thing is that you have to do it correctly. I remember there was somebody that had multiple servers, but with the same key, or had every key in the same computer. He got his house.
Some network that's been live, right?
Yeah. And he had some issues with the law. So, anyways, I'm not against it. I think it's a useful thing, but in general, I'm more a big fan of FEG on CK. On TEs are cool, but they're not that useful yet. I don't know the experience of the rest, but from my point of view as a normal engineer, it's not that simple to use.
But they're not equivalent in terms of intent matching. So FEG is not really applicable naturally to it, so comparing them in this context is not exactly correct. So
yeah, I didn't meant it on intents. I'm speaking more business-wise, like on the three technologies or 4 WTEs. The ones I see the more interesting or practical are FEG on CK.
Yeah, I agree. FEG is cool, just not usable for intent matching.
Yeah.
Louis, do you think Starkware will start exploring TEs, FEG, MPC?
No.
I think they have enough work.
The short answer is no, and fuck no. The reason why, there is a reason why. So the reason why cryptographers kind of hate TEs, as a rule of thumb, is because it's hardware. It's a hardware security. It's not the same business, and writing an algorithm or Circle Stark or whatever BNews, whatever primitive, that nice, cool, pure algorithm. It's not the same skill sets, not the same people. So the short answer to that question is no. But but there is a junction though in between the two, which I find super interesting and not talked enough about it, which is and goes back to the point I was making about the trustless card dealer, which is, to me, the end game of ZK rollup is to basically be provable servers, meaning if blockchain are in the internet of money, we will need web servers that can understand what the blockchain is, that can run fast, and that can survive the death of the creators. And the only way you get that is through ZK. The thing is that if you have a centralized party, what you're risking is obviously liveness, and also this party knowing everything about it. And so TEs, in that sense, can make it more their action most trustworthy. So there is, in my opinion, a very strong tie between the future of what ZK rollup would be and what people talk about L3s. L3s will not be decentralized because that's not their goal, but they might be running in TEs for the privacy perspective, for providing the unbiasedness that is you lose when you build on a centralized environment.
Yeah, that makes sense. I think we're closing to the end here, and I think we'll have time for Connor and Shumo to make a closing statement, if you'd like.
We at Celestia have an interest in making the base layer more censorship resistant than Tendermint, because we want Celestia to be useful for base rollups, and we want it to be possible to try to do things to reduce MEV or recapture MEV or whatever. And improving censorship resistance is one way to do that. And so we like the threshold encryption schemes that have been proposed by Osmosis with the Fervio scheme and Penumbra with the flow encryption scheme. Although more likely than not, we're going to end up solving censorship resistance without those schemes, probably doing some sort of multiple concurrent proposers or Narwhal Bullshark or something like that.
Yeah, I guess my take here is that I think TE is not that bad. I don't think you should use TE as the only security guarantee, but I do think it's very reasonable to use TE as an additional security guarantee, especially, let's say, if you're building a rollup or a rollup stack, you want to do a multi-prover. I think TE is an excellent choice on that regard. And also, I think one thing that didn't mention by many people on TE that if you look at the vulnerability of TEs, most of them are side channel, which means they are privacy leakage rather than verifiability issues. So if you're using TE purely for attestation or verifiability, I think the security vulnerability in practice is much less. So with that, I do think we probably going to use TE as additional security guarantees as a multi-prover system. Yeah.
All right, so in the last 4 minutes, we have explored intent, cryptography, intent settlement, intent matching, and intent matching seems to be the open frontier where TEs are currently required. There's different cryptography advancements that could be made in that realm. Overall, a lot of open research still, and let's thank our panelists for their insights. That'll conclude the session.
Thank you.
Actually, sit that back down, Luis. We do have time for 2 questions. If anyone has, please. Oh, okay, questions.
Yeah, in the discussion on definitions, everyone seemed to settle on this idea that a intent is some kind of preference function over a set of state transitions. And then Shumo had the point that you can specify this as constraints, and this has the property that you can aggregate all these different people's constraints, and you have this like set of constraints to solve. How do you think about what you're optimizing for when you're solving these sets of constraints? I mean, intent as an object is not like a transaction where you have gas or whatever, so like what are you actually solving for when you have this big set of constraints?
Yeah, the honest answer is I don't know. Because I think we, as a settlement layer, mostly want to provide the infra to give the solver or searcher the ability to solve that, right? So this is really the solver's job, and I'm not an expert on the solving side. Yeah.
Yeah, thank you guys. To follow on the question of Sino, just to Yulia, I wanted to get more information. I personally work for Polygon Maiden, so we're a private Zk rollup, so I work on privacy most of the time. And I know it's really a non-trivial task to implement. And so I know you've kind of skimmed over it, but I was just curious, how did you concretely implement privacy into your protocol? Because, for example, right now, if you take Penumbra, Polygon Maiden, Aztec, etc., most of them are implementing client-side proving with ZK and stuff like that. And I was curious, if you looked into these things or how you imagine potential privacy on your protocol, and just I don't know if Anoma is alive yet, but if not, and you need to also implement privacy, it's gonna take you I don't know, multiple years. So if it's a core part of your protocol and it's not ready yet and it's being researched, I'm just curious, what is the state? Because it's non-trivial.
Yeah, so as I mentioned, there are roughly 2 parts, intent matching part and settlement part. So settlement part privacy is implemented by Taiga. It's a privacy preserved instantiation of a resource machine. It's inspired by Zcash, so there are commitments, nullifiers, and all that stuff, zero knowledge proofs, encryption, everything. So if you're familiar with Zcash, you'll be able to understand it. So that's how we do privacy for the settlement part. And as I mentioned, for the intent matching part, it's up to applications, basically, and there is no concrete solution yet.
But then you're leaking data when you're sending your intent from the user to the application. Then the application has all the information of the intent from the user, right? So it's not really private. It's private on the the searcher side, the solver side, but it's not private on the application side, right?
No, so I think applications are not exactly like an entity that you send your intents to. You send your intents to solvers, and application is somewhat ephemeral here. So when you have privacy at that layer, for example, you use TE, so you send your intent to TE, multiple intents to TE, inside TE they're checked if you can match them, and if they match, you create a transaction from that, an output transaction. So that's how you get privacy on that intent layer part. With MPC, it's a bit more complicated, but more or less the same. It's just instead of T, you have multiple parties executing MPC protocols.
Thank you. I'll look into it.
Sorry, just getting back to the solving question a little bit. I think, in my view, if you actually being able to formalize the constraints solving problem, then you can having a optimized solver to solve that. There are many good commercial solvers previously I checked that some of them developed by like a commercial companies like IBM. So for solving side, you don't need to trust them, so that's fine. I think the real question is, can you actually translate the constraint satisfaction problem formally from a user's intent to this mathematical language? I do think like Anoma people here has more expertise than me on this regard. Maybe they can provide some insight on that.
Yeah, I think recently Chris wrote a forum post about that, about matching intents that are written in like human language and how to transform it into mathematical form. And as far as I remember, there are 2 proposed ways to do that, but I don't remember the way, so you have to head to the research forum. Yeah.
Right. Thank you very much. This was really intense. Let's bring our hands together. Can the next, oh right, just a comment. I did mention the art reports. Yulia did write a report about private solving. As mentioned also here, is one of the hardest problems right now in applying cryptography to decentralized systems. In case you're interested in doing research in this domain, feel free to reach out.